Welcome to our session on solving equations. Here are the two main things that we're going to learn. First, we're going to learn how to solve equations the right way every single time. All right, every single time. And then number two, really this one is emphasizing, well, what equations really are in terms of how we're solving them. And when you look at an equation that takes one step versus two steps versus 3 or 4 or 10 steps, I don't care. My goal for today is to help you understand that, look, it doesn't matter how big the equation is, you're still following the same general idea. So for those of you that have been to a previous class before, I want to make sure that those who are here for the first time really understand this. For those of you that have been to a class of mine before, true or false, when it comes to learning topics, every single problem within that topic follows the same general idea. Yes or no? Okay, again, if you're on your laptop, there's the chat box right there. If you're on your phone, you might see that little chat bar blowing up on top or on bottom. But look at all these folks right here that have been to classes before. You know what I'm talking about. There's the same general principled idea for every single topic. And as long as you learn the main idea, you've already set yourself up for success, because it's learning the main idea, then practicing, correcting any mistakes, and then mastering. And as long as we can stick to the main idea, that's where it all starts. So here we go, my math party people. Let's go. Here are the 4 steps of equation solving. I'm going to go ahead and let anybody here take a screenshot, and then I'm going to zoom in to let you write each individual step. Okay, so here's the 4 steps of solving equations. I'm going to really read them out one by one for us, and then I'll zoom in just in case anybody's on their phone. And again, if you are on your phone, I highly suggest turning your phone sideways. That way you can see more of the screen. Coach, smile for the picture. And that's as much excitement as they'll get out of me today. So with that said, here we go. Step number 1, when it comes to solving equations, if there's anything that you can simplify, go ahead and do it. So if you see on the same side of the equation, like a 1 plus 2, hey, combine that, do your thing. You know, simplify whatever you can when you can. Now, we're not going to get into that too much today because most equations that you see are typically already simplified. But if there is any simplification to do, like breaking on parentheses or distributing or something, you do want to keep an eye out for that. But we'll see that maybe in the later problems in today's class. For right now, you don't really have to worry about step 1, but know that it is a factor later on. So again, there's number 1. Number 2, this is the biggest key right here. As always, my ASVAB party people, thank you for watching this video. Before we continue, just wanted to remind you that if you're struggling with the ASVAB, if you struggle with test anxiety, blanking out on problems, then you need to consider the ASVAB All-Access Program. Thousands of my students have tried it out, and they have always raised their scores if they used it the right way, because there's always a way to learn for whatever method you like best. From recorded lessons, to live classes, to guided practice videos, to printable worksheets, to speed drills to help you test and raise your confidence and speed, to casual practice that comes with video solutions. Every single way that you can think of, over 10,000 questions, all of it lined up for you, ready for you to get started right now. So at the very least, check out the link in the description so you can see exactly how it works and why, again, over 1,000 of my students have raised their scores with it all the way through. I'm proud of you. Let's keep working hard, and let's get back to the video. But don't forget, check out that program. I think you'll like it. Moving all parts of the equation that have a variable on it, make sure that that's all on one side. So like if you see a 7x or a 3x or a 10x or whatever, make sure all of that is on one side. And all the regular old numbers, make sure that those are by themselves on the other. So for example, you need to make sure that if your problem starts like this, if your problem starts as, let's say 2x plus 5 equals 17, you need to make sure, or actually make this a little more illustrative. If we have 2x plus 5 equals, let's go ahead and say, let's make this a little more illustrative. So if we have 7x plus 5 equals, let's say 3x plus 27, something like that. If we have a problem like that, step number 2 right over here, this is all about turning this, all of this right here, turning that into this, getting the variables on one side and the regular old numbers on the other. That's what I'm saying here. You want to make sure that everything that's a variable, move that over. Anything that's just numbers, move that over. Everybody, yes or no, so far does that make sense? the first thing, or the second thing technically, you should be looking to do is to get the variable by itself. And you do that by getting anything with a variable on one side, anything that's just numbers on the other. And don't worry about how we're going to do it, because I'm going to teach you that, but just know that that's the idea, isolating the variable. Right, in this case, Rachel, yeah, I subtracted, but I'll go ahead and work with you on how to get that done for sure. And no, it's not bad at all, De Santiago. No, not at all. If you're going ahead and moving between topics, I would only recommend that, because you're in the math bootcamp, make sure that you have a great, and I mean great, not just good, not okay, but I mean great understanding of the topic that you're currently at before you decide to start skipping around. So if you were working on fractions and then you moved over to solving equations, I would love to see that you're absolutely good on adding, subtracting, multiplying, dividing fractions, and then working with them in problems. Because if you're not quite there, then it's not the quite right decision to move on. So with that said, once you get to this point, and I'm gonna teach you how to get to these points, but once you get to something like this, really it's gonna be a game of just getting the variable by itself. That's what it's always been about. That's what it's always gonna be about. And it's gonna be really by working with the opposite operations. So I'm gonna write this down for us. It's actually gonna be in the next slide. Yep, it's gonna be in the next slide, so we'll get to it. But I'm gonna repeat this again in the future. Solving equations is the art of working backwards. Has anybody here ever heard me say that in class, on YouTube, or anywhere else? Solving equations is the art of working backwards. Hey, right on. I'm glad you guys are paying attention. I love that. Love that, love that, love that. So next up, again, isolate that variable by performing opposite operations. We will be going over that as well in a moment. And then lastly, while you practice and while you're learning the topic the right way, checking your work. So for example, if I were to say, hey, man, we have x plus 2 equals 5, and then we somehow, we did the work and we went ahead and got something like, yeah, x equals 1. I'm not saying it's the correct answer. I'm not saying it's not the correct answer. All I'm saying is, and I'm going to take some shots at y'all, sometimes, and I'm not talking about everybody, but sometimes I do get some text messages or I do get some questions online or on Facebook saying, hey, I solved this equation. I got x equals 1. Can someone tell me if I'm correct or not? Here's the thing though. You have the power to figure out if you're right or wrong. And it's called checking your work. And you check your work with solving equations by plugging the number back in. So allow me to just elaborate on what that means very quickly so I can show you what power you have today. So if I were to somehow get x equals 1 for this equation, I could check my work by plugging it back in. And here's what that means. That just means going ahead and taking the equation and literally replacing x with 1. That's exactly what that means. So if I erase the x and I replace it with the 1, everybody, is that true? Is 1 plus 2 equal to 5? No. And so that's how you can check your work. You can literally solve the equation. And if you have a question in terms of like, okay, did I get this right? Did I get this wrong? Plug it back in. Plug it back in, see if the math checks out. And if it does, hooray. If not, you got a little more work to do to understand your mistake. Everybody, yes or no, does that make sense in terms of checking your work? Again, yeah, you can absolutely plug the variable, the number that you got back in to see if it's correct. And again, we're going to go over plenty of examples in today's class. I got your back. So with that, oh, Niaja, I actually just saw your review on Google. Everybody, give me a second for Niaja. Congratulate Niaja. She just passed, y'all. Go ahead and give her a good congratulations. And I'm going to go ahead and mute that mic in 2 seconds. Go ahead.
Yeah.
Congrats. I wish you the best in your future.
There it is. Congratulations, Niaja. I appreciate you for reaching out to me about that too. And also keeping up with me, please. I want to know more about what's going on. So with that said, my party people, let me go ahead and zoom in to steps 1 through 4 here. Again, step number 1, simplify both sides of the equation if you can. If you have a parentheses to break, you want to break it. If you got numbers that can be combined, do your thing. Do your thing. Number 2, Once you're done simplifying both sides of the equation, you want to basically, again, move anything that has a variable on one side, anything with it's just a number on the other. Totally fine. Then from there, once you have the variable pieces by itself and the regular numbers on the other side, then it's really time to finish the job. We're simply going to be performing the opposite operations to go ahead and isolate that variable. And again, I'm going to show you plenty of examples of what that looks like today. So don't worry if you're taking notes right now being like, I got no idea what he means. Don't worry. The notes and the main ideas are just pretext to the actual practice. Once we get both in, you'll start building those connections naturally. I got you. And so lastly here, number 4, check your work. Like we just said, once you get your answer, feel free to plug it back in and you're good. So with that said, my party people, I will give you one more chance to go ahead and take a screenshot here, and then we'll be going into the next slide. And again, congratulations again, Naisha. She came into class to get that props and then she dipped. I love it, man. I really conditioned y'all to really be proud of the scores you got, man. And I love seeing that. I love seeing that. So here we go. Solving equations here. We got to make sure we know how to combine like terms. Everybody, if you see something to the effect of, let's just go ahead and say, 2x plus 2, is that equal to 4 or 4x? Is that equal to 4 or 4x? The answer here is going to be no. 2x and 2, those are not like terms. So let me go ahead and give you some proper examples here to show you exactly what I mean here, my party people. I got y'all. So here, a good example. This is bad right here. That is no-go. If you have something to the effect of, let's say, 2x plus 3x, that's going to be 5x. That's good. That's good. If you have something to the effect of, let's say, 2 plus 3, that'll be 5. However, if you have, let's say, 2x plus 3, well, guess what, my party people? That's just going to be 2x plus 3. You cannot combine those because they're not like terms. Like terms have the same variables and the same exponents. And so if you're looking at 2x and 3, that's just going to stay 2x plus 3 because those cannot be combined. They are not like terms, and you just leave them alone. So, Teo, I'm glad that you saw that there. Just want to make sure that we're all good. And yeah, for sure, I want to give you guys a good refresher. So very briefly, one more time. If you have the same variables or same letters with the same exponents, yeah, you can combine them for sure. 2x plus 3x, that's 5x. 2 plus 3, those are like terms because they're just numbers. Yeah, that'll be 5. But if you have a 2x plus a 3, that's just going to stay 2x plus 3. There's nothing else you can do, and that'll be it. So before we continue, again, one more time, because we're going to keep ramping it up little by little. Yes or no? Does this make sense so far? No, Nikki, if they're on the opposite sides, you do want to make sure that they're on the same side before you combine them. Yeah, you can only combine things that are on the same side of the equation. And again, I'm going to show you plenty of practice with that too. Yeah, gotcha. Good question. Great question. So let's talk about combining like terms and party people here again. When you're combining like terms, and here's your example here on the side. Again, you're like terms. For them to be like terms, you have to have the same variable and the same exponent right here. Same variables and same exponents. And I do believe someone earlier asked what kind of a tablet I'm using. I'm just using an iPad Pro. I don't know if you're trying to copy me or do whatever, or you're inspired by this, but yeah, it's just an iPad. So with that, let's go ahead and talk about some bigger ideas here. So right here, when you are combining like terms, we're going to go ahead and basically keeping the same variable once we actually add them. So just to kind of briefly go over it again, when you're looking at something like 2x and 3x being added together, you're just adding the 2 and the 3 to make 5. You're basically saying, hey, I got 2 of these x's plus 3 of those x's. That means we now have 5 total x's. So they're the same kind of term, so you're allowed to combine them. But if you have it saying, hey, I got 2 of these x's and then just the number 3, that doesn't mean you have 5 x's. It just means you have 2 of these x's and 3. That's it. There's nothing to combine. But there's a big idea that we really need to drive home before we get started, and it's right here. The key rule of solving equations, everybody. One, whatever you do to one side, you must do to the other. Whatever you do to one side, you must do to the other. Please write that down. I will be quizzing you on that all day long. And number two, solving equations is the art of what? You know, you already had it written down. Go ahead, Marie. Yep. Working backwards, working backwards, working backwards, working backwards. I know a lot of y'all always like start creeping and waiting for me to ask the question to answer it. I know. So let me go ahead and fill that in for us. Let me get that yellow right here. Working backwards. Okay. Solving equations is the art of working backwards. If you've never heard that before, well, it's your lucky day, because you're going to learn how easy equations can be as long as you stick to the main fundamental ideas. Those fundamental ideas are literally right here. Number one, whatever you do to one side, you must do to the other. And number two, work backwards. As long as you continue to try to work backwards, you're going to get it right. And as long as you're doing the same thing to both sides, you will be correct. I promise you. So I'm going to take you or give you a few moments. Go ahead, take a screenshot, do what you got to do. I got a few props here, but I'm not going to use them right now. I want to keep this class pretty locked in, pretty serious today, even though I joke around a lot. But go ahead and take that picture if you need to. I'm going to let Caleb in, and we're good. Cool. Give you a few more moments. And let's get to work, guys. There we go. Hopefully that was enough time. Hopefully that was. So some extra tips here. Today, we may not be going over fractions and decimals with solving equations, but just understand that numbers are just numbers. Decimals, fractions, percents, whole numbers, negatives, they're really all just numbers. And as long as you know how to deal with them individually, when you mix it into solving equations, it's going to be fine. But just know that if you're looking at a solving equations problem and you see a decimal and you freak out, your problem is not with equations. Your problem is you're not strong with decimals. So you should and need to take the time to be fluent in that. So I'm going to ask this question for those of you who have been there before. Who here has experienced a great growth after you've taken the time to learn mental math, to learn how to deal with decimals, how to deal with fractions, how to deal with negatives? Who here has seen a huge jump in their confidence by really mastering the fundamentals? So again, like, don't take it from me. Like, this is experience and this is proven. If you work on the fundamentals, you'll have a lot more to work with in terms of your confidence level. It's like the whole saying, I don't know if you've ever heard this before, but you can't build a house on mud. If you've ever heard that before, just listen to it again. You can't build a house on mud. If you build the most beautiful, magnificent house, but you have a poor foundation, chances are you're going to have to build that house again starting next week at the most. But if you take the time to lay the groundwork and have a great foundation, you can build a house that can last over 100 years. And that's the idea. You can't build a house on mud. Really focus on those fundamentals. That's what I always tell people who are in the program first. Make sure you got your decimals down, fractions down, negatives down, order of operations. Because once you translate those ideas to the bigger topics, like solving equations, proportions, or distance, rate, time, you won't have an issue because you have your foundation set. So with that said, let's go ahead and go through some warm-ups here. First things first, everybody. That's right, Rashad, a little bit every day goes a long way. So let's go ahead and have a little pop quiz, my party people. What did I just say? Solving equations is the art of what? Everybody type it out. Everybody type it out, type it out, type it out. Solving equations is the art of what? Yeah, working backwards, working backwards. Can't say it enough, man. Working backwards. That's what solving equations is all about. And so let's go ahead and really understand what's going on here. Let's understand this. I'm going to first look at number one. Remember, my math party people, acing the ASVAB is not just about watching me do it. it's better that you practice as well. It's about watching, practicing, and mastering the material. And the best way to do that is to start off with my free practice test, because it comes with video solutions so you can try it out yourself, see all the mistakes that you've made, and then keep raising your score with those video solutions, organizing yourself so you can lower that test anxiety and raise your score. No excuses, it's completely free, so go ahead and click the link there or in the description. That way you can get started, raise your score, and do everything you need to do. Let's ace the ASVAB, but let's get back to the problem after you're done signing up. So we have 6 equals 8 plus k. Okay, 6 equals 8 plus k. Now, here's the thing. If I were to frame this a little differently, I guess I bet you a lot of you would be a lot more comfortable with this problem. Everybody, is 6 equals 8 plus k the same thing as 8 plus k equals 6? Can I swap the side in an equation and it'll still be true? Yeah, absolutely. So let me first go through the basics with y'all, because there's so many little things that in the math world, like with a lot of teachers seem to assume that you know these things, but I really want to just demonstrate it so that way you can really feel and understand why it's true. So what I just did was very simply showed you that you can swap the sides of an equation. The whole sides, you can swap them. You can. Because here's the thing, everybody. 1 plus 1 is 2, and 2 equals 1 plus 1. It doesn't matter which way you say it, it's still true. So yeah, you can go ahead and see it that way if you'd like to. Here's another thing I want to show you. Did everybody here know that if I say 8 plus k equals 6, well, that's the same thing as saying k plus 8 equals 6. Do we understand that those are the same thing? And Justin, you're good. I got your message earlier. So does everybody here know that if you have 8 plus k, that's the same thing as saying k plus 8. 1 plus 2 is the same as 2 plus 1. Really need to make sure I drive that one home as well, because again, there are so many little things that we feel that are true, but we haven't confirmed it or haven't had it like shown to us. So I do want to make sure that that's there. When it comes to subtraction, yes, absolutely, as long as you move the sign with it. And don't worry, we'll have plenty of examples where we can go ahead and show that. But now that we have it in this form, k plus 8 equals 6, let me show you what I mean when I said solving equations is the art of working backwards. Everybody, what's the letter that we're looking for here? Like, what are we trying to solve for here? Go ahead and type that out in the chat box. Yeah, we're looking for k. We're looking for k. So if I check this out right here, we're looking for k. And so we have to ask ourselves, well, first, what is going on with k? Because once you understand what's going on, then you can work backwards to figure out what k is. Here's what I mean. Everybody, if I'm looking at k specifically, everybody, what is currently happening? Now, I'm not saying what should we do. I'm not asking what we should do. I'm asking, what do you currently see is happening to the k? What is currently happening to the k? And I'm going to go ahead and circle it or box it in right here. That is what's currently happening. What is currently happening to the k? Right, we're adding 8 to it, right? We're having 8 being added to it. And so, like I said, solving equations is the art of working backwards. And whatever you do to one side, you do to the other. So with that said, everybody, what is the opposite of adding 8? Right, we want to subtract 8. And again, we're starting slow here, starting nice and calm. But once we get into those bigger and bigger problems, you'll see that, yo, this is the same stuff. As complicated as it might look, it's still the same thing. And I got you. So if we currently see that we're adding 8, we're going to do the opposite and subtract 8 on both sides. So right there, boom, minus 8 here, minus 8 there. The reason that we do the same thing to both sides, everybody, is simply because think of like a balancing scale. So it's not too heavy on one side or the other. It's perfectly balanced. Everybody, if you remove half a pound on one side, but not the other, it's going to instantly tip over. And so when you think about equations, I want you to think about a balancing scale, a perfectly balanced scale. Whatever you do to one side, you do to the other, because you want to keep the balance. Yes or no, everybody? Does that make slightly to a lot of sense? Think of equations like a balancing scale. This side equals this side. And whatever I do to this side, I do to the other to keep that balance. And that's why here, if I'm subtracting 8 on the left side, I got to subtract 8 on the right side because it'll cancel out over here, giving us that k by itself that we wanted. And on the right side, everybody, what's 6 minus 8? What's that going to be? Yeah, so the majority of us are saying -2. Some of us said 2, and that's okay. But the answer will be -2. If you're having trouble with negatives, don't worry. There'll be plenty of opportunities here with problems that won't have those negatives. But the answer here will be -2. And here's why. When it comes to subtraction, it's actually a pretty straightforward concept. If you have 8 minus 6, you're basically saying, what's the difference between 6 and 8? And yeah, that's going to be 2. But if you're doing 6 minus 8, you're basically going the opposite way. If I have 8 and take away 6, I have 2 left. If I have 6 and take away 8, I owe 2. I took away too much or too many. And that's why when you go the opposite way, if I'm looking at 6 minus 8, guys, just do 8 minus 6 and make it negative. Same idea, same idea. And so there it is. And that's why k would be -2 in that case. But I'm not here to teach you about negative numbers. All I'm doing is just really illustrating that these two rules are always in effect. Whatever you do to one side, you do to the other. And when you're solving equations, you're essentially working backwards. So far, so good, everybody? So we can move on to the next one. Right on. I'll give you a second to go ahead and write anything down if you need to. But we're going to go ahead and show problem number 2 coming right up. Okay. And there's number 2 right there if you want to take a gander at it. All right, cool. Let's go ahead and tackle number 2 here. And again, if at any point you need me to repeat myself or ask questions, I got you. Please do. So number 2 here, we have 4 equals p over 11. Okay, 4 equals p over 11. Guys, remember this. Whatever you do, you're trying to work backwards. So I noticed that p is already right there. There's no other p's anywhere else. It's just a p right there. And I'm taking a look and I'm saying, hey, I'm trying to get p by itself. Everyone, quick question. What is currently happening to the p that is really not letting it be by itself? Like, what is bothering the p right now? Right, that division, dividing by 11. And if you didn't know, a fraction means the top divided by the bottom. All right, it's the top divided by the bottom. So if you're checking this out, we have the p right there. And we see that we're dividing by 11 right here. And so remember, the art of solving equations is working backwards, or solving equations is the art of working backwards. So if I see that I'm currently dividing by 11 and that's going to give me 4, I need to perform the opposite. Everyone, serious question, but a redundant one, but a serious one. What's the opposite of dividing by 11? Correct. Right. Multiplying by that 11. Now I want us to go ahead and type that out again and really complete the logic here. What we should be saying is the step that we're taking is multiplying by 11 on both sides. So go ahead and complete that thought there. Multiply by 11 on both sides, and I'll perform it for us, and we'll keep moving. There we go. Love seeing that. Yep, there we go. Cool. Right on. So again, if we're dividing by 11, to cancel that out, you got to do the opposite. And so what that means is we will simply go ahead and say, hey, I'm going to multiply by 11 here, multiply by 11 there. That's how you multiply or do the same thing to both sides. Jalissa, this is solving equations today. And so with that, that's how this cancels here on the right side. And then from there, we're just left with p by itself. Everybody, 11 times 4 is going to be what? 44. Exactly. And we're good. So remember, if you're sitting here being like, hey, coach, this is kind of easy. Don't worry. You probably haven't been to many of my classes because the torture the fun, it's going to come pretty soon, okay? Give us about 20, 25 more minutes, and we're going to be getting into those tougher and tougher and tougher problems. So yeah, the fun's coming. I got you. So here we go. Number 3. I didn't say that, Rachel. I might have slipped out. So let's go ahead and go to number 3 here. Number 3. So here we're looking at 4 equals 17 plus x. So a lot of people seem to misunderstand questions like this because we may not be seeing what operation is happening with the x. But my party people, let's see if we know this. What is currently happening to the x? What operation is currently happening? What operation is currently happening? Right, there's a 17 being added. So let me just make this distinction, okay? Everybody, just remember, if I'm looking at 17 plus x, that's the same thing as saying x plus 17. These are the same thing. These are the same thing. 1 plus 2 is the same as 2 plus 1. So if you just see a number just chilling there by itself, like you see that 17 right there, that 17 is being added on that side. If there's just a number there, that number is being added to that side. And so my question is this, everybody. What should we do? What's the opposite thing that we should do to both sides? Right, we're going to work backwards, and that would be subtract 17. Thank you for correcting it, on both sides. If we want to get rid of that 17, to break that box to just get the x by itself, we have to do the opposite operation, and that'll be taking away that 17 here and here. Remember, treat it like a balancing scale. We got to make sure we keep the weight balanced. So we'll take away that 17 on both sides like that to keep the balance preserved. And so boom, that gets canceled out on the right side. And again, you may feel like this is torture because we're saying, hey, coach, we're dealing with negatives again. What did I just teach you? If I'm doing 4 minus 17, that's the same thing as 17 minus 4. Just make sure it's negative because you're taking away a lot more than you have. It's just the opposite direction. So again, 17 minus 4, that's 13. 4 minus 17, that's negative 13. So here, that'll be negative 13. And that's the answer. And that's it right there. So again, if you're not terribly strong with negative numbers and dealing with negatives, don't worry. We got plenty of opportunity to practice that. I have plenty of activities in the math bootcamp. I literally have I think it's like a 10-part series on just dealing with negatives. So make sure you're in there if you're in the program. It should be the 2nd or 3rd section of the math bootcamp, going straight into mental math and calculating. That's actually section 2. Yeah, section 2. So with that said, there's another problem that we can again do by simply working backwards. And I want to show you number 4 here, because again, it's the same idea. And Santi, no, you can write x equals negative 13 or negative 13 equals x. Same thing, right? Same thing. So here we go, number 4 for the last one here. We have 90 equals negative 5b. Quick question, my math party people. 90 equals negative 5b. Okay, cool. Everybody, remember, we are trying to get the b by itself. So my question is, everybody, what is currently happening to the b? What is currently happening to the b? Right. Currently, what we are seeing right now is multiplication. We are currently witnessing multiplication being shown. So right here, I want to make sure that you are understanding what's going on. Everybody, negative 5b, that's the same thing as saying negative 5 times b. That's what that means. If you are attaching a number with a variable, multiplication is happening with that number and that variable. If you're looking at the negative, thinking that that means subtracting, you're subtracting 5b, but you're not subtracting 5 from b. You're subtracting the product of 5 and b. So I really need to make sure that we are very, very, very aware of that. We are multiplying -5 and the b. -5 is being multiplied by the b. But before I continue, yes or no, do we understand that? -5b means you're multiplying -5 and b. The negative is just a sign. The negative is just the sign. So the entire term is -5b. And what is happening is that -5 is being multiplied by b. Want me to prove a point? Here we go. I can go ahead and give you this. And give you -5 with the parentheses. Instead of saying b, I'll say 2. So everybody, if we're looking at -5 and then the parentheses 2, or -5, 2, that means that we are multiplying -5 times 2. And everybody, what's -5 times 2? Right, that would be -10. Just showing you a brief little example. Multiplication just happened. So if we knew what b was, right over here, we would be multiplying that by the -5, if we knew what it was. But the point of this is, everybody, we don't know what b is, and we're trying to figure that out. And so in order to figure that out, we're going to perform the opposite, not sign, but the opposite operation. Notice how with number 2, we didn't go here and multiply by -11. No, we saw that we were dividing by a +11. So we multiplied by a +11. If I'm looking over here, hey, I'm multiplying b by -5. So now I'm going to divide both sides by -5. And again, that negative is very important. Very, very, very important. And for my word knowledge folks out there, very important, we could replace that with imperative. It's imperative that we do the opposite to both sides, the opposite operation. If we're multiplying by -5, we're dividing by a -5. If we're multiplying by a 3, then we divide by 3. Don't worry about the sign, it's about the operation. So you have to understand, to get this right, you got to understand that when you're attaching a number to a variable, that is multiplication. This is just the sign of that coefficient. It's just the sign, but you're looking at the operation. So we divide both sides by -5. So now let's go ahead and see over here. 5 goes into 90 how many times? Okay, cool. 5 goes into 9 one time. And so with long division, we can subtract the 5. We'll get the 4 left. Everybody, 5 goes into 40 how many times? Right, that's going to be 8. And so 5 goes into 90 8 times. But it's not going to be 18. It's going to be -18, because remember, a positive divided by a negative is going to be a negative. B equals -18. Yeah, it would be a -18. The same rules for multiplication are the same for division. Positive times a positive, that's a positive. Negative times a negative, that's a positive. If the signs are opposite, you get a negative result. So a positive divided by a negative, that's negative. Negative divided by positive, that's negative. Cool. So Vivi, let me make sure I got your question there. I'm going to scroll back to make sure I got it. So let me see. When do I know which operation to use? So yeah, Vivi, like I said, you have to notice first what operation is happening. That way you can identify the opposite. So the opposite of addition is subtraction. Subtraction is addition. Multiplication is division. Division, multiplication. Then you also have like squares and square roots, and we'll get to those in another great lesson that we're going to have planned up for this month. No, it's supposed to be 90 divided by -5, not the other way around, Jasper. 90 divided by -5. And so with that said, looking at the 4 problems that we were just able to do, my party people, I want to ask you this. Which of these, number 1, 2, 3, or 4, which of these do you feel was the hardest for you to wrap your head around? Yeah, and it could be none. Could very well be none, but I see a lot of us saying 2, a lot of us saying 4. Yeah, if it's none, yeah, it's fine if it's none. Yeah, okay, 4, about 2s, 4s, okay. 4, but some practice could do me justice. No worries. Right, like it could feel easy for you, but it could be tough for someone else. That's all good. No worries. Okay, no worries. So here's what I want to do now. I want to go ahead and give you guys the opportunity to go ahead and try some of these out yourselves for sure. And I want to see, well, can you reason with yourself while you do this? So make sure that while you go through these questions, this next set of guided warm-up questions, I want you to go ahead and first identify, well, what operation is currently happening, and then perform the opposite operation. Because remember, if I take 5 steps forward, then 5 steps backward, I end up right where I started. If I go 5 steps to the right, then 5 steps left, I end up right where I started. And right where you started is the variable. So after this set, we're going to go into a tougher set of problems and tougher and tougher and tougher after that. But let's make sure we cap this one off here. I'm going to give you just about here. Let me get the timer up. I'm going to give us about 2 minutes here for this set. All right, so there's the timer. The timer has started, so go ahead and give this a shot. Then we're going to go over it, and then we're going to review this, and I'll take any and all questions that you guys have. So let me get my face out of the way so you can focus. I'll give you 2 minutes, and we'll be right back. Go ahead. So we have 9 equals n over 20. So remember, it's all about opposite operations here. So here we go. Checking out opposite operations, we have n. And right now what's happening to the n is that it's being divided by 20. So if we want to work backwards, going from the outside in, if I want to get rid of that 20 right there, well, what's currently happening is dividing by 20. So to get rid of that division of 20, I'm going to do the opposite and multiply by 20. Because I know that if I divide by 20 and multiply by 20, I end up right where I started. And that's how we know that this will work. So we'll go ahead and multiply by 20 on both sides, right there and right there. And what ends up happening is on the right side, it cancels out. Boom. And that's what's going to leave us with n by itself. And now that we have that, we're all good, because 20 multiplied by 9 is what, everybody? Right, that's going to be 180, and we are good. So number 1 was 180. And again, if you didn't get that, just remember, we're trying to understand what is the opposite operation. That's really what we're trying to understand here. But that is number 1. Let's check out number 2. So was anybody here hesitant on number 2 for the simple reason being that we weren't that comfortable with negative numbers? Kind of see some yeses. I see a lot of no's, which is a very good sign. But I see a lot of us here are a little nervous about negatives. And so with that said, here's the thing. Stick to the rules. Stick to the rules. If you have a hiccup because of the knowledge or the lack of practice, then log that and then get that practice in. But here, what are we looking at? Well, I'm looking at, hey, I'm trying to solve for P. And right here, I see that we're subtracting 16 from P. And that's how we get that negative 33. Everybody, the simple question to ask yourself is this. What is the opposite of subtracting 16? Right, the opposite of subtracting 16 is adding 16. That's the opposite. And so that's what we'll take care of right there. Boom. I'll add 16, but not just to the left side, but to the right side. And if you're taking care of business here and you're looking at this saying, hey, how do I do negative 33 plus 16? Guys, that's going to be the same thing as just saying 33 minus 16, but keep it negative. Whenever you're adding opposite signs, really it's just about subtracting them and keeping the sign of the bigger number. Now, I'm not going to be sitting here giving a sermon on negative numbers, but I will refresh you on those rules as we go along. My ASVAB party people, hope you're enjoying the math party so far. Just wanted to remind you before we continue that we do have a way for you to practice everything you need to get the ASVAB score that you want. Because in our math boot camp, we have everything you need in terms of recorded lessons to go through the entire concept. On top of that, we have guided practice, printable worksheets, and speed drills for each and every single mini concept, from adding and subtracting decimals to fractions, distance, rate, time, word problems, proportions, everything you need. It's all lined up for you, and it makes learning as easy as possible. And we make updates to this course on a weekly basis at no extra cost to you. So I really urge you and implore you, go ahead, check out the link in the description for the Math Bootcamp, which is also included in our full program, and we make it as affordable as possible. So go ahead, click the link in the description to learn about this more. That way you know exactly what's available to you to raise your score. I don't want you to feel test anxiety. I don't want you to feel like you're lost and you're just hoping for the best. I want you to take control of your studying, and the ASVAB All-Access Program and the Math Bootcamp are the exact ways to do it. So if you have any questions, my contact info is also in the description. But before we continue, please check it out so you know exactly what's available to you. That way you can feel confident that there is a solution for you. Let's get back to the video though. Let's ace the ASVAB. So 33 or negative 33 plus 16, that'll end up being negative 17. So again, here's how I want you to take a look at this, my party people. I do not want you to look at this and say, man, I don't know how to deal with negatives. No, I want you to look at this as, I know that the way to get the right answer is by adding 16 on both sides. That's what I care about. I don't care about you, like, at least right now, I don't care about you, knowing how to deal with negatives or decimals. It's about the process and the reasoning why. Do you know why we're adding 16 to both sides? So if you saw this right here, you got this step good, that's really all I care about. That's what I care about. Now, if you don't know how to deal with negatives, don't worry about it. We'll practice that. We'll get that work in for sure. So again, 33 plus 16 for one last time. To follow that rule, you're basically going to do 33 minus 16, but keep it negative. Keep it negative to get negative 17. Yeah. So with that said, my math party people, we are going to move forward into number 3. Again, if you're sitting here focusing on how did I get negative 17? How did I get that? You have to learn how to work with negatives. That's not about solving equations. That's a problem with working with negatives. You got to take time to work on that. Here we go. Number 3, we have 1 minus p equals 9. There are really 2 main ways to get this done, everybody. There's 2 main ways. Here's the first way. First way that I would have seen a lot of people do this one is like this. A lot of people would have been like, hey, I want to go ahead and get rid of the 1. Now, everybody, just quick question. Is that a 1 being subtracted or being added? Like, as you currently see it, is that 1 there as a positive 1 or a negative 1? I want to know from your end. Oh, no worries, Jordan. We'll get there. And yeah, I want to make this very clear. Everybody, that 1 sitting right there is a positive 1. It is simply a positive 1 sitting there. If I want to get rid of a random positive 1 just sitting there on the left side, what am I supposed to do? Right. I'm going to be subtracting 1 on both sides. So let's go and get into that here. Subtract 1, subtract 1. Everyone, if I go ahead and do that, here's what happens. I go ahead and have a positive 1 and a minus 1. That's going to cancel out. And then 9 minus 1 is going to be what, everybody? Yeah, 9 minus 1 is going to be 8. Okay, sounds good. Here's where I feel like a lot of people might feel like they're getting confused. Because notice how we didn't do anything with that negative right there on the P. We didn't do anything with it, so it stays there. We're still dealing with negative P. That's it. So here's the thing. We got to get rid of that negative somehow. Now, everybody, here's the thing. If you have a negative P equals 8, well, here's what you can do. Everybody fill in the blank. When it comes to solving equations, whatever you do to one side, you blank. Right. Whatever you do to one side, you do to the other. Whatever you do to one side, you do to the other. So what that means is this. If I have a negative P and I want to make it a positive P, isn't it the same thing as just like applying a negative to that side? Like if I wanted to turn a negative to a positive, if I just apply a negative, negative is a positive, right? A double negative is a positive. So I could think about it that way. You could also divide by a -1. You could multiply by a -1, but really it's all the same thing. When you're dealing with changing the signs, really it's like this. You can just say, hey, I can make that a positive P by just attaching a negative to it. But I have to make sure that whatever I do to one side, I do to the other. And that's it. Whatever I do to one side, I got to do to the other. And so I got to attach a negative there. And so what that turns into is a positive P equals -8. And there it is. Again, some of us might see it as multiply both sides by a -1 or divide both sides by a -1. All that does is it changes the sign. That's it. So if you want to change the sign on both sides. If you have a negative P equals 8, that means P equals -8. Change the sign on both sides, and you're good. You can change the sign on both sides. Yeah, so another example here is this. I can write a couple more examples so you guys can illustrate this a little better too. I got you. So if I'm saying, hey, -x equals -3, you can just change the sign on both sides and you can get x equals 3. Another example, if I had like -7 or -x, or let me just use -k equals, let's say 4, that means k equals -4. Remember, what you do to one side, you do to the other. If you want to change the sign on one side, change the sign on both. That's what we're saying. Whatever you do to one side, do to the other. Some of us might see it again as multiplying both sides by a -1 or dividing both sides by a -1, but the rule is the rule. If you want to change the sign, do it to both sides. Does that make a little more sense for anybody? Cool. Cool, I'm glad to see it there. Yeah, so just to review this one last time here, I got you. So here with number 3, again, what we did was, hey, let's get rid of that 1 first. And what that meant was, well, that's a positive 1 just sitting there, so we subtracted 1 on both sides to do that. Once we subtracted 1, this got out of the way, and we were left with the P here. Ignore the red, ignore the red. We were left with that negative P, and that was equal to 8. We wanted to get rid of the negative on the P, and our understanding says, hey, look, if you have a negative or a negative times a negative, that becomes a positive. So to get rid of that negative, I applied another negative, but you do it to both sides. So in that case, what you would have is a negative giving you that positive, and then you apply the negative over here, giving you that -8, giving you that -8. Okay. And so let's take care of this last one here, and then we're going to get into 2-step equations. This one's going to be really interesting because now we're going to be adding more than one step. And I want you to really understand that, yo, as long as you know what's going on, you can work backwards. So no worries, Hunter, I got you. We're going to get plenty more examples here, I got you. But number 4, -2 equals P minus 6. So my part of people, if we're checking this out, again, all you have to ask yourself is this: what is currently happening with the variable I'm trying to solve for? Answer me that, please. What is currently happening around the P? Right, on its same side, what's currently happening is it's currently being subtracted by 6. Currently being subtracted by 6. And so notice how I keep drawing these boxes. A lot of you are being, looking at this saying, okay, I understand what's going on. I don't know why you're drawing those boxes. Once we get into 2-step equations, you'll see exactly what I mean in terms of why I'm drawing these boxes. So we have a P and we have a -6. Everyone help me out here. How do we get rid of that -6? Miguel, that's correct. Everybody be specific here. Add 6 where? Add 6 where? To the other side, the right side, both sides. Both sides, both sides, both sides. There we go. Way to be proper. Yes, to get rid of that negatives or -6, you will add 6 to both sides. So doing that right there, that's going to cancel out on that right side. -2 plus 6. Well, everybody, -2 plus 6 is the same as 6 minus 2. It's the same thing. And so everybody, 6 minus 2 is what? It's gonna be a positive 4. Yeah, that'll be a positive 4. So that's the answer that we would have gotten here. P, 4 equals P. 4 equals P. Right, just 4, not negative 4. That's correct. So just to give you a little better hint of that opposite stuff, again, negative 2 plus 6, you can go ahead and move the 6 up front to make it 6 minus 2. Same deal. Yeah. So the thing is with adding and subtracting, like you can move things around, but you got to move it with the sign. Negative 2 plus 6 is the same as 6 minus 2. Right, exactly. And if you have negative 2 plus 6, you subtract the numbers and keep the sign of the bigger number. 6, the positive 6 is the bigger number, and so you keep it positive. That's correct. Yeah. Yeah, Nikki, I'm glad that you like the boxes now, because once you get into this next part here with two-steppers, man, it's going to be pretty interesting here. It's going to be pretty interesting. So let's go ahead and get into 2 steps here for guided warm-ups. And just want to take a quick pause that for those of you who are interested in the full program, you can absolutely go to that link right there. I don't want to wait all the way into the end of class because I do know that some of us have to go. We got work, got to get ready for tomorrow. You can always go to that link right there. I'm going to type it into the chat box for a brief moment. So again, if you are interested, let me go ahead and stop the chat box real quick. And here we go. Let me just type this in here just in case anybody does need to go early, because it does happen. So here is the link. And you can use the code Monday, all caps, for a nice little discount. I do offer it month to month, cancel whenever, or you can get the full year. You get everything I offer: classes, recordings, courses, practice, everything you need. So I am going to go ahead and just put that in right there for you. That way you're good. And I'm going to open up the chat in just about 5 seconds. 4, 3, 2, and 1. So if you're interested, again, click that link, save that in your browser. That way you can go ahead and get into it after class ends using that code to get a massive discount. That code only works until tonight at midnight. So with that, boom, there it is. Chat box is opened back up. And so Dilio, and so if it's smaller than the other number, it's a negative. That's correct. So if it was 2 minus 6, or you could say, yeah, you could say a negative 6 plus 2, that would be a negative 4. Yeah. And so Miguel, I'm glad that you've identified that. And it's really just about understanding opposites. That's really it. So here's what I want to do first, my party people. What I want to do first is I actually want to work on this one with you first. I know I just skipped over 3 problems. Don't worry. I want to first show you number 2, because I want you to appreciate that solving equations literally is the art of working backwards. So here we go. Let's take a look at this 2-step equation, everybody. Let's write this down again. 2-step equations. And again, if you are in the program already, I have everything from 1-step equations, 2 steps with fractions, with variables on both sides, complicated ones with parentheses and things like that. It's all in the progression with the guided practice, worksheets, and speed drills. So if you miss anything at all, don't worry, in the Math Bootcamp, you have everything you need. So let's get into this here. Everybody, what is the letter of the variable we're looking for? What is the letter? Quick, give it to me. We're looking for B. I know someone had a question there. I just want to make sure I don't miss it. All right, no worries, Taylor, because this is exactly what we're going over now. So here, number 2, yeah, we're looking for B. So let me go ahead and just highlight B. Let me go ahead and put a box around it. And again, for those of you that were like confused about why I was using boxes, don't worry. Don't worry. I'm about to show you up. I got you. So there we are. Now my follow-up question is this, everybody. Remember how I was asking earlier, what is currently happening? So everybody, now here's my new question. My new question is, what is the first thing that's happening to B? Is it being multiplied by 9, or is it subtracting 10? What is the first thing that would be happening to the B if we knew what it was? What does order of operations say we should be doing? Right, look, you guys got this. Look at that. Every single one of us said what is currently happening. The first thing, order of operations, says we are multiplying by 9. You're absolutely correct. Good job. Like, seriously, good job, because you can identify the forward steps, which tells me good and well that you're going to be able to identify the backward steps. So here, multiply by 9. That's what order of operations says. And then the next thing, after you have that multiplication of 9, I think it's safe to say that the next thing that we would be looking at is the subtracting 10. And so everybody, here's what the boxes are there for. The boxes are there from all the other examples and to this one here. All the boxes are doing are showing you the order of operations moving forward. Because if you look at this, everybody, look. B, you would multiply by 9, then you would subtract 10. And when you do all of that, whatever that is, it's going to be equal to 170. So everybody, if we're working backwards, we're not starting with B, we're starting with the outermost box, the last step in order of operations. We're working backwards from the last step. So when you do this, look at how much easier this can feel. Everyone, what's the first thing we should do? Add 10 to both sides or divide by 9 on both sides. Which one should we do first? What is the outermost box? What should we do first? Yeah, we should add a 10 on both sides. Absolutely, absolutely. Because look at how beautiful this turns into. Or look at the beauty that this turns into. Excuse me there. So once we add 10 to both sides, look at what happens. This cancels out. And then we're left with 9b equals, well, 170 plus 10. That's going to be 180. But take a look, my math party people. Take a look. Boom. Now we've gotten rid of that outer box, and we still got to get rid of that red box that has the 9 in it to get to B. Notice that solving equations is literally working backwards outside in. We're trying to remove everything we can to get to the variable. So now we have 9b equals 180. Everybody, what's the opposite of having the 9 there with the b? What is the opposite? Right, dividing by 9. As a reminder, when we just have a number and a variable, that's called a coefficient. A coefficient pretty much just means you're multiplying that with the variable. 9b means 9 times b. So the opposite would be to divide by 9 on both sides. That would be the opposite. And so notice that when we do that, let me change colors really quick. 9 gets eliminated, and then we just have the b by itself. Then we receive the b by itself. And that's going to be equal to 180 divided by 9, which would be 20. And there's our answer. And there's our answer. So let's just review this one more time. And I'm going to ask you guys how much sense that made. So here's the reasons why we did everything we did. I used these boxes to pretty much show you the order of operations moving forward. That way we can easily see how to work backwards. So you notice that you would multiply, then subtract. So that's the last thing you saw, subtract 10. That's the first thing we're going to work on. The opposite of subtracting 10, adding 10 on both sides. And then from there, okay, great. Now we're just left with that 9 and b, 9 times b. So then we will do the opposite of multiplying by 9 by dividing by 9. And we're still following the same cardinal rules. Whatever you do to one side, you do to the other every time. And also, we're working backwards. We took away 10, so we add 10 to both sides. We're multiplying by 9, so we divide by 9 on both sides. Follow those two rules, and you'll never go astray. You'll never be led astray. So everybody, yes or no, or kinda, is this making sense? Just the idea of working backwards. Because I'm telling you, like, this is how we set ourselves up for success. This is exactly how we're going to set ourselves up for success. We have to understand the fundamentals. And we're going to keep getting more and more and more difficult. If you're still here at 7:21, we still got 40 minutes. I'm going to show you problems that people always freeze up on. But once you learn how to do things like this, you're good, man. You're good. Oh, hey, Miguel, that's a pop-up. Go ahead and just click X on the pop-up, okay? Go ahead and exit out of that pop-up and you should be good. I'll actually turn that pop-up off right now to make things very easy for you. Don't worry about that. I'll turn that off right now. But again, let's go ahead now, my party people, and let's get into the next one here. All right, let's get into this next one. So again, Miguel, if you refresh it, you won't have that issue anymore. I just fixed it. So here we go. The answer here is going to be 20. Now let's go ahead and get into a problem like, let's go ahead and go up here and let's do this one, number 1. All right, so when we take a look at number 1 here, b minus 10 over 28 equals -1. Who here is experiencing a little bit of anxiety? Who here is experiencing a little bit of anxiety looking at something like that? Okay, so here's the thing. You have received the training up to this point that will help you succeed with this. Full stop. Full stop. Order of operations, working backwards, doing the same thing to both sides. You have everything you need to get this done. Let me show you how a lot of y'all overthink when you see something that you haven't seen before. Again, follow the same rules. Look at this. Everybody, let's work forward before we work backwards. So I know that I am looking for the mysterious b. So I'm going to go ahead and put that in a square there or a little box. Okay, great. Now, here's where people often get confused. Everybody, when you're looking at b minus 10 over 28, let's work forward. If you knew what b was, would you subtract 10 first? Would you divide by the 28 first? Which would you do first? Do you apply the 10 first or do you divide by the 28? Which one would happen first? And I see why everybody here is confused. Because again, as long as you understand your order of operations, this won't be that big of a deal. Here's what I mean. Everybody, when it comes to a fraction, answer me this. Quick question. Let's go ahead and say we're looking at, let's say we have 11 plus 5 over 3. Everybody, is it true that if you have something like this, 11 plus 5 over 3, is it true that you got to treat the whole numerator as if it were a group? Because 11 plus 5 over 3 should be 16 over 3. Like you have to add what's in the top first, right? You got to look at the top and understand that that's a group. You're saying your whole numerator divided by your whole denominator. And this is something that not a lot of people recognize, but this is something that you have to know. When you're looking at this, you need to understand that 11 plus 5 is the entire numerator. That needs to happen first. Notice how I just put a parentheses on it. Notice how I just put a parentheses on it. That whole numerator, you have to do that first, and then you divide by whatever's on bottom. And so, yeah, 16 divided by 3 is not a pretty number. Don't worry about that. I want you to worry about what's happening moving forward. Because if you can understand this, then you can absolutely understand this. You can absolutely understand this. Let me move this over to the side for a brief moment. Make it small right over there. So what I need you to understand is that this is a whole group up here. That's a whole group. And so what that means, my party people, is that moving forward, you're subtracting the 10. And then once you're done subtracting the 10, then you divide whatever that result is by the 28. So this is what the box should look like right there. That is the order of operations that we're currently looking at. Everybody, before I continue, does that make sense? You have to first do everything in the numerator, and then you divide by that denominator. And so I'm getting some no's, and that's okay. That's okay. I want to go ahead and just, let me go and explain this in a different way here. So let me go ahead and show you, then back to the example. I'm going to give you the similar example with different numbers, but let me give you a different example here. Let's say we're looking at, let's give the example of 10 plus, and then let's go ahead and say 4 over 2. Let's say we have 10 plus 4 over 2. Here's the idea, everybody. You cannot just say, hey, I'm going to do 10 divided by 2, and then I'm going to add 4. If you do it that way, look at how wrong this is. If I do it that way, if I do 10 divided by 2 first, that's going to give me 5, and then add 4. And then you get 9. This is incorrect. This is incorrect. The reason being, everybody, look. Notice that the 4 is also above the 2 as well. It's the 10 and the 4 above the 2. It is the 10 and the 4 divided by 2. But look at the mistake that we just made. The mistake was I only divided the 10 by 2, and then I ignored the 4. I ignored it like the 4 wasn't getting divided by anything. And if you do that, you get 9, and that is incorrect. That is incorrect. The correct way looks like this. If I go ahead and draw the exact same thing, 10 plus 4 over 2, the correct way is to say, yo, the entire numerator is a group. It's the numerator divided by the denominator. So that numerator is 10 plus 4. And when you work on that, that'll be 14 over 2. And 14 divided by 2 is 7. That's the correct way to do it. So before I continue, everybody, do you understand that this is the correct way to interpret a numerator and a denominator in terms of a division problem? And this is incorrect because notice how you're only dividing one piece, not both, not everything in the numerator. This is the correct way. It's the entire numerator divided by the denominator. And if we understand that, what you should be able to see is this. I'm going to move slowly over and show you exactly what's going on. When you're thinking about moving forward, is this. You're saying, hey, I'm going to subtract 10 from B, and whatever the result is, you divide the whole thing by 28. Remember, solving equations is the art of working backwards. You want to work backwards from the last step. First, you take away 10 from B, then you divide by 28, and you're done. So if we're working backwards, the last thing that I told myself was dividing the whole thing by 28. And so that's why, everybody, the first step is multiplying both sides by 28. Before I continue, before I even do any of the math, yes or no, does that make sense? Why we're multiplying both sides by 28 first instead of adding 10? Like, you cannot add 10 to both sides because look, if I tried to add 10 to both sides, that simply would not work. Notice that if I added 10, that's a fraction over 28. I got to get through this first before I can get to the 10. I have to get through the 28 first. And that 28 is dividing by 28. Opposite of dividing 28 is multiplying by 28. So I really do want to make sure that this makes sense. And again, if it's not still making sense, that's really why the program is there. So you can get that practice slowly but surely, one by one, concept by concept. But I do need to make sure that we understand that and how to move forward the right way. Because now what we're going to do is we're going to proceed. But remember, it's about opposite operations. When we do the multiplying by 28, that cancels out. And notice what we have left. We're going to have B minus 10. And again, I'm going to keep the same exact boxes that we had right there equals, well, everybody, a negative 1 times 28 is going to be what? Correct. That's going to be negative 28. Right on. And now take a look at this. Now, when we take a look, well, everybody, what is the opposite of subtracting 10? Right, that's going to be adding 10 on both sides, exactly. That's going to be adding 10 on both sides. And boom, here we are good. Because what's going to happen here is, bam, we're going to go ahead, cancel out the plus 10 minus 10. And so then we're left with B by itself. And so negative 28 plus 10, same thing as saying 28 minus 10, but just keep it negative. Because the 28 is the bigger number, so you keep it negative. So that's going to be negative 18. And that's going to be negative 18. So I know this feels tough because the thing is, at the end of the day, a lot of us are really only used to solving those very straightforward, I'm not going to say easy, but the basic ones, the fundamental ones. But the thing is, to be able to do these harder questions, you do have to be aware of your fundamentals at the highest level. So yeah, the answer there would be negative 18. Now, with that said, I do want to allow you guys to get some practice on your own. I do want to show you number 2 here in a moment, but I do want to give you guys an opportunity to try some practice out on your own before we come back and looking at these other examples, okay? So Delio, go ahead and ask me that via text, because again, that's going to be a question about dealing with negatives, and you want to make sure how to deal with negatives since you're in the program, or I think you're in the program already. You want to make sure you go to that section to handle it. So with that said, I want to make sure we get that practice in. So here we go. I want to give you guys the opportunity to try out numbers 1 and 2, and I do believe numbers 3 and 4 as well up next. So for numbers 1 and 2, I'm going to give you exactly 2 minutes, 1 minute per, or if you want to take the whole 2 minutes for just one of the questions, totally fine. So here we go, my math party people. Let me go ahead and set this timer up for you because I want you to get this practice in. Timer has started, and go ahead right there. And again, as always, type ready when you're ready. So since the beginning of class, this should be something that feels like a long time ago, and it should feel pretty solid with us now. Again, this is a one-step problem. We can go ahead and get this done, by honestly just looking at it if we wanted to. So everybody, here we have 15 equals n plus 16. We want to get the n by itself, and we see that there is a 16 in the way. So to get rid of that 16, we subtract 16 on both sides. Booyah. And what we have right here, bam, cancels out. So 15 minus 16 is going to be -1. The reason being, 16 minus 15 is 1. So 15 minus 16 is -1. If you go the opposite way, there you go. And that's why B here is the correct answer. Now, that one for a lot of us might have felt pretty good, and I love that. But now let's go ahead and take a look at number 2. Number 2 being that torture that we just saw in the other problem, that other example. So let's go ahead and try to understand number 2 a little better here to see what we got. So number 2. 6 equals 10 plus b over 2. Okay, so let's take a look. Let's just zoom on in here. Everybody, you have to understand what's happening moving forward. It's all good, Tramel. It's all good because this is where that practice comes in, right? So let's go ahead and do the boxes here. Let's make things look pretty. I'm trying to get to that b right there. And what I notice is happening to the b, currently is that we're adding that 10 first. And then what's happening after the fact is then we are dividing the entirety of that numerator by 2. Like everybody, the boxes work. There is no way that you would be able to draw these boxes if you thought the 2 came first. No way. No way you would be able to. Let me go ahead and fix this up a little bit here. There. There is no way that you would be able to draw the boxes from B, then to 2, then to 10. There's no way you would be able to. You would cross the 10 immediately. So this is a good way that you can tell that, yeah, you know which way is forward. First, it's the B plus the 10, then all of it divided by 2. So now when we're going backwards, we need to get rid of that 2 first. The opposite of dividing by 2 is multiplying by 2 on both sides. So once we do that, boom, that's going to cancel out right there and there. And then we see that everybody, what's 2 times 6? That's going to be 12. And we have 12 equals 10 plus b. So allow me to go ahead and grab this again. Okay. And so now that we're here, now we just need to get rid of that 10 and we're good. Hey, really quick before we continue, if you're watching this, you've likely have already been to one of my classes. And if you haven't been to one of my classes, remember to check that schedule. The link is right up there and in the description of this video. That way you can understand when my free classes are and my access program classes are. That way, you can keep raising your score, knowing what topics we're doing, and get the job you want. So again, click there or in the description to see when the classes are and join one for free. I'll see you there, my party people. Let's get back to the action. And the opposite of just having a 10 there, well, taking away a 10. We'll go ahead and subtract that from both sides, and we are good. Once we do that, that cancels out there on the right side. And what we have is 12 minus 10 being 2. And we'll have 2 equals B. There's the correct answer. And we can go ahead and party like it's 1999. Booyah. Tramel, there we go. Who here's feeling pretty good about solving this when they were pretty apprehensive about this before? That's what I'm talking about, guys. There we go. There we go, man. I'm really enjoying this because, again, at the end of the day, we're looking at, well, I put in a lot of negatives in this class, and I did that on purpose because nobody's safe. I don't want to baby you guys and make you think that all the numbers are always going to be pretty. They're not always going to be pretty. You're going to have to deal with negatives, and you got to learn how to deal with them. And then on top of that, you got to learn how to deal with really curious situations like having a fraction involved. So, right, you got to take your time. You've got to take your time. So I want to go ahead and give you guys another round of practice here, another 2 minutes, and then I'm going to show you how to do this one last kind of example. Then I'm going to have you look forward to the math bootcamp. Again, if you are in the math bootcamp, I'm actually going to walk you through. So if you're in the program, stay until the end of class because I'm actually going to show you my computer screen and I'm going to show you exactly where to find everything for solving equations for this here. And you're going to love it because it goes from step 1 all the way to the most complex type. So here we go. Here's another set of questions. You got numbers 1 and 2 right there. And I'm also going to show you what we're doing tomorrow, which is a brand new class. So here is this one, math party people. Let me go ahead and start that timer. Timer starting right now. And let me get my face out of the way. Timer's up. Face is gone. Get to it, my math party people. Go ahead and type ready when you're ready. Here we go. Practice 3 plus 4x equals a negative 49. Again, everybody, look. I'm going to draw my little boxes here and I'm going to show you that, hey, look, these boxes are not just for decorations. These are actually going to be very helpful. And then once you get used to it to the point where, hey, I know what I'm doing, then you can go away from doing the boxes. Honestly, what I want you to get to is being able to do this without even writing anything down. Like, for example, if I'm looking at this, I'm saying, hey, 3 plus 4x equals negative 49. So first I'll subtract 3 from both sides, then I'll divide by 4 on both sides. So subtract 3 on both sides, we have negative 52. Negative 52 divided by 4, that's negative 13. Boom. And you'll be able to do that as you learn and as you keep going forward. So with that said, let's go ahead and get it done here. I'm looking at this and I'm saying, hey, x is the goal. X is the goal. And I see that what's immediately happening to the x, everybody, is it's being multiplied by 4. It's not immediately being added by 3. No. It's immediately being multiplied by 4. And then after you complete that multiplication of 4, then the 3 comes into play. And so now we have to consider, again, working backwards. Now we consider working backwards. First thing we got to get rid of is that 3 to get closer to the x. So if I get rid of that 3, subtract 3 on both sides, boom, that's going to cancel out here because a positive 3 minus a 3, it's gone. Then we have negative 49 minus 3. Everybody, if you're already negative 49 and you take away 3 more, so if I took away 49 and I take away 3 more, I took away 52. Negative 52. That's more negative, exactly. It is more negative. So we have 4x equals negative 52. Let me get these boxes back in here. Booyah. And so then the last step that we'll take is understand that we got to do the opposite of multiplying by 4, which is going to be dividing by 4 on both sides. And so booyah, there we go. Divide by 4, divide by 4. And then we're left with x equals negative 52 divided by 4. And if you didn't know, well, 10 times 4, 40. 11 times 4, 44. 12 times 4, 48. 13 times 4, 52. So the answer will be negative 13. And so again, we got negative 52 because negative 49 minus 3 is negative 52. Yeah. Yeah, and if you needed to see it the other way, for sure, my party people, you can absolutely do it the other way. 3 plus 4x is the same thing as 4x plus 3. If you wanted to see it that way, you absolutely could. Absolutely could. Absolutely could. Absolutely. So the answer here is going to be B, negative 13. And again, and ignore those curly braces. Ignore those curly braces and you're good. Now, do we have any questions here before I go to the second one here? Is that the only one with a positive sign? How do you mean only one with a positive sign? Do you mean the 4x being positive? Go ahead and elaborate on that. Any other questions here before I move on to number 2? Any other questions here? So yeah, Maria, right here. Again, this is an issue about dealing with negatives. A negative number, and then you subtract, you're getting more negative. So for example, if I had, very briefly here, if I had negative 5 minus 3, well, I'm already negative 5, and I'm getting negative by 3 more. Or you could say, I took away 5, negative 5, I took away 5, then I took away 3 more. So in total, I took away negative 8. Same thing here. I took away 49, then I took away 3 more. So that's a total of taking away, or negative 52, because 49 plus 3, 52, but negative 52. So hopefully that sounds good, Maria. Perfect. So with that, let's get into number 2 here. And then we are going to wrap things up. And again, I'm going to show you exactly where to find your practice in the math bootcamp. That way you can really get into it there. And then I'm going to talk about the program and we're all good for the day. So number 2 here, we have x minus 1 over 7 equals negative 2. Now, everybody, just before we begin, there are plenty of other types of solving equations problems that you need to be aware of. So there's other ones that include fractions, there's parentheses involved, there's variables on both sides. And so that's why I'm really making sure I'm emphasizing that you got to expand your practice space here. You got to embrace it too. But let's go ahead and get started here. We have x minus 1, all of it over 7 equals negative 2. So here, if we're taking a look at what's happening moving forward, well, I'm trying to get that x by itself. And then from there, well, again, you do the whole numerator first. So what we're really looking at is subtracting 1. And then from there, after the fact, then you divide the entirety of whatever x minus 1 is, you divide that by 7. So if we're looking forward here, it's subtract 1, then divide 7. Work backwards. The dividing by 7 is the first thing we got to get rid of. We got to get rid of the dividing by 7. And so, boom. And so with that, we will go ahead and do the opposite of dividing by 7, and we will multiply by 7. That's how we get rid of that right there, leaving us with x minus 1. Let me go ahead and just copy this over. Right over here. Booyah. And then everybody, negative 2 times 7. What's that going to be? Right, negative 14. Negative 14, nice and easy. And so with that said, again, a negative times a positive is a negative. So 2 times 7 is 14. So a negative times a positive gives you that negative 14. Now, the last thing we need to do here is get rid of that minus 1, which means that we will add 1 to both sides. We'll add 1 to both sides. And that's how we're going to get rid of that minus 1 right there. And that's gone. And now we're dealing with negative 14 plus 1. Everybody, negative 14 plus 1 is the same thing as 14 minus 1, but negative. 14 minus 1 is 13. It'll be negative 13. X equals negative 13. And boom, we're good there as well. My party people, as always, thanks for watching. Please make sure you're subscribed to the channel. That way you can see all the updates that we come out with so you can keep improving. So don't wait, subscribe now, and then while you wait for the next video, look here or there to see a related video that's going to help you improve even more. Let's keep raising that score, and let's get the job we want. I'll see you soon.